Okay, today we're going to be looking at motion under gravity. Let's get myself sorted in order. And the key thing with motion under gravity is being very consistent about your positive direction. As a rough rule of thumb, I would make mine positive whatever direction U is. So example 1, I'm going to read out from our sheet, says a stone is dropped from the top of a 20-metre tower. How long will it take to reach the ground? So I'm taking, it's being dropped, so it's neither one direction or the other really, but I'm taking downwards to go on positive because that's where all the motion is. So what it means is S is 20, that's its displacement in the positive direction, U is 0, V is what we're after, one of the things we're after. A is plus G, plus 9.8, and T is something else that we're after as well. So we're finding time first, so it's the one without V. S equals ut plus a half at squared, so 20 equals nothing, and then a half a is 4.9 t squared, so t is whatever root 20 over 4.9 is. It's around 2, so I'm going to work out 20 divided by 4.9 equals, and then do root, answer equals that mess there, 2.02. And I can't do much beyond 3SF there. If I want what V is, it's the one without T, so V squared equals U squared plus 2AS. So V squared will be equal 2 times 9.8 times 20. Oh gosh, is that a nice number of 14? Let's have a look. 2 times 9.8 times 20 equals 390. Oh, not quite. 14 root 2, I think the answer is. And then root ans equals 14 root 2, 19.7, 19.8 meters per second. So all the direction was downwards, that's no positive there. Example 2. A blue and yellow rubber ball was projected vertically upwards from ground level with a velocity of 28 meters per second. So since it's projected vertically upwards, that's my positive. I've got two different questions to do with two different points. What's the maximum height? So there's A. And how long did it take to return to the ground? Now, it's a badly worded question, that part B, and I'll come to that later on. So for A, I want the height, I'll call it H for height. U is 28. At the top, V is equal to 0 because it's maximum height. Since I'm measuring upwards to my positive, A will equal minus G. I'm not interested in the time at all, so I'm quoting V squared equals U squared plus 2AS. So 0 equals 28 squared, and then minus 2 times 9.8 times S. So S will equal whatever 28 squared is over 19.6. So 28 squared divided by 19.6 equals 40 meters. That's its height. For part B, how long did it take to return to the ground? It's not very clear, the word in the question, if that means from the top to return or from when it was thrown to return. So I'm going to take the overall time from when it was thrown. So I'm taking S to be back to 0. U is 28. Because it's at exactly the same height, it's going to have exactly the same value as speed, but in the opposite direction. So if I needed it, V will be minus 28, but I don't need it really. A is minus G and T is what we're after. So it's the one without V. So S equals ut plus a half a t squared. 0 equals 28t minus a half g, 4.9 t squared. I can divide by t. T is not equal to 0 because I'm not interested at the start, I'm interested in the end. So t is 28 over 4.9 equals 28 divided by 4.9 equals 5.71. 5.7 seconds. Okay, so far so good. Example 3 says, ball is thrown vertically upwards from ground level at 20 meters per second. A boy with large hands leaning out of a window 8 meters above the point of projection catches the ball on its way down. So Notice my diagrams are more projectile-like. Even though it's vertical motion, it's quite hard to show the up and down in a single straight line. So I'm exaggerating it to look a little bit like a projectile. What's the time and how fast is it travelling? Okay, so I've got my 3 bits of information. It sets off there, so upwards is my positive. I'm measuring it that way. So S equals 8, positive. A is minus G, U is 20. So I want T first, so it's the one without V. S equals UT plus a half AT squared. So 8 equals 20T minus 4.9 T squared. So 4.9 T squared minus 20T plus 8 equals 0. Oh gosh. 49T squared minus 200 T plus 80 equals nothing. I don't think that's going to factorise. So let's have a look then. This is a bit of a pain, to be honest, when you haven't got a super duper calculator. Plus 80 over 49 equals 0. So we're going to have 10,000 minus 80 times 49 equals that. Can I root answer? That divided by 49 equals, and then because it's T plus it, it's the second of the 2 times, so it's T plus this answer, so it's 100 divided by 49 equals, and I've got 3.63, the bigger of the 2 times. So if you stick it in the quadratic formula, it'd be I should have done the quadratic formula actually. It would have been the bigger of the 2 times there. To find V, it's the one without T, so V squared equals U squared plus 2AS. V squared equals U squared, 400, and then minus 2 times 9.8 times 8, so 400 minus 19.6 times 8 equals, whatever that is, 243.2. Don't forget to square root the answer to get 15.6. V is minus 15.6 meters per second, or 15.6 meters per second downwards. You have to take into account that at that height there, it would have a velocity of 15.6 upwards as it was going up, and 15.6 downwards as it's going down. Okay. And similarly, example 4 wants how long is it above a particular height. The same sort of idea is thrown up with 29 meters per second, and I want the difference between the 2 times when it's at 34. So, yet again, S equals UT plus a half AT squared, 34 equals 29T minus 4.9 T squared, 4.9 T squared minus 29T plus 34 equals nothing. T equals, I'm going to use the formula this time, 29 plus or minus root V squared, 29 squared minus 4 times 4.9 times 34 all over 9.8. Now, what's going to happen here is one time is going to be 29 plus the root over 9.8, and the other time is 29 minus the root over 9.8. When I do T1 minus T2, I'm going to get whatever that root is doubled and divided by 9.8. And I can show you by doing 29 squared minus 4 times 4.9 minus 34 equals whatever it does, 174.6. So root that is going to be about 13.2. So 29 plus that is going to be about 42 over 9.8, 4 of it. So bracket 29 plus my answer divided by 9.8 equals 4.3. And then I've got to do it all over again, I'm afraid. 29 squared minus 4 times 4.9 times 34 equals root answer equals, and 29 minus that equals divided by 9.8 equals 1.61, 1.6108, and then 4.307 minus answer equals difference between them 2.7 seconds. T2 and T1 to be more precise. T2 minus T1 is the difference between 2.7 seconds there. So work out your 2 times, minus them, and then that's our answer there. Last example. So there's a competitor made a dive, and yet again, initial velocity is 4 meters. It lands below where it set off, 5 meters below. So because the initial velocity is upwards, I'm taking that to be my positive direction, which means I'm moving S is minus 5, A is minus G, U equals 4. If you choose to make downwards your positive, then you can say S is 5 at the bottom there, A is equal to plus G, but you would have to specify the initial velocity of 4 is negative because it's going in the opposite direction to your positive direction. So yet again, we want V, we want T. Guess what? S equals ut plus half at squared again. So minus 5 equals 4t minus 4.9 t squared. 4.9 t squared minus 4t minus 5 equals 0. Stick in the quadratic formula, t equals 4 plus or minus root. And in this case, it has to be one value t will be negative, the other value is going to be positive. B squared, so it's 4 squared minus 4 times 4.9 times minus 5, because that's going to be bigger than, all over 9.8. So 16 plus 20 times 4.9 equals 114. I can root my answer with that, and then 4 plus that equals divided by 9.8 equals that mess, 1.497, 1.5, 1.50. Like that. To find the velocity, the one without t, yet again we're seeing the ones that crop up the most here. So v squared equals u squared, 16, and then it's plus 2 times 9.8 times 5, because it's minus 9.8 minus 5. So we end up with a bit. I'm expecting v to be bigger than what it was before. So 98 plus 16, 114 again. So root 114 equals whatever it does, 10.7. V squared equals 114. V is minus 10.7 meters per second, or 10.7 meters per second downwards. Okay, so in that case there, we've got to look carefully at what our plus and minus direction is. And that is all there is to motion to gravity.